Moving down into subcortical terrain, again, we have the falx cerebri, we have the tentorium cerebelli, we have the corpus callosum, we have the ventricles, we have the basal ganglia. Here you can see a little bit of the hippocampus and the amygdala. An important distinction here, again, geographic term, supratentorial. So we just saw the down here, the tentorium cerebelli. Things above this are supratentorial and things below this are infratentorial. This is just a natural invagination folding of the brain, which is really hugged tightly and strongly demarcated by the meningeal dura. And so anything above is going to be supratentorial, anything below is going to be infratentorial, largely, again, to separate the cerebrum from the cerebellum. So a couple things we're going to be going through now are going to be some subcortical, so that is to say below the frontal lobe, temporal lobe, parietal lobe, occipital lobe, but supratentorial, so above that tentorium cerebelli. This includes the corpus callosum, the lateral ventricles, just 1 and 2. We have ventricles 3 and 4, which are going to descend down infratentorially. The basal ganglia, which is several different structures. Limbic system, which is several different structures. Also very arguable. People debate about what is the cohesiveness of the limbic system. The thalamus, largely a relay station, and the hypothalamus pituitary axis. So the corpus callosum is just going to communicate the sort of left and right side of the brain. You can see it here. You can see it very clearly here, connecting the right side here with the left side. We can see it here. So it's basically the most superficial aspect of the brain, apart from the cerebral cortex. And again, you can see it here as well after we've sort of taken out the cerebral cortex from our picture. So 1981 Nobel Prize. This is kind of amazing. People who have severe epilepsy, to prevent the spreading of electrical signals like wildfire throughout the brain, they cut the corpus callosum so that it can't spread as much, and this kind of stops it. But that means information can't be shared between the left and the right. And again, remember that when in doubt, left part of the brain has to do with right sensory system and right motor skills, and then vice versa with the other side. So here's a person, they've had their corpus callosum severed. They see the word face. It's on the right side of the visual field, which means it goes to the left part of the visual brain. We said that the language center is on the left side. So somebody says, hey, what do you see written? And that is in the left part of the visual, the left part of the brain, that information. And they can speak with the left part of the visual brain. So they go, I see the word face. Okay, well, let's put this now in the left part of the visual field. That goes to the right part of the brain. Now, though, that information, that the word they see as face, cannot cross to the left part of the brain because the corpus callosum is severed. So if they need to communicate that with verbal speech on the left side of the brain, well, the left side of the brain doesn't know what we're seeing, right? You and I take for granted that there's a sharing of information between the corpus callosum. So they will say, I don't see anything, because again, there's this separateness of the left and right hemisphere. But the writing skills are intact just on the right part of the brain. So they say, I don't say anything. That's the left brain being unaware because it can't communicate with the right brain. But the right brain can control the left arm to write that they see a face. Kind of amazing. The lateral ventricles, so we have this whole ventricular system. These are just the lateral ventricles. They kind of look like the horns of a ram. And the ventricles are going to play a role in the generation and flow of cerebrospinal fluid, which provides nutrients and takes away waste. Kind of like water coming to the house, right? Water coming as nutrients, taking away sewage is taking away things that we don't want, the output. And it's going to have a complex drainage where the cerebrospinal fluid will ultimately drain into the venous system to get out of our head. So three very important systems really are the basal ganglia, limbic system, and the HPA axis. Again, there's going to be fuzzy borders with everything. All of these are supratentorial, and we'll take a deeper look into each one of them.